So hello everyone and welcome to my session on Azure Synapse Analytics Pipelines, a 360-degree view. So my name is Carrie Payette and I am a senior software engineer with Trillium Innovations, and I'm also a Soliance partner. I'm an Azure MVP and a Microsoft certified trainer, and you'll typically find me usually neck deep in data and hardware. I really love hardware. I also like to seek out those interesting programming languages and frameworks that I can leverage every day in my work. So let's go ahead and take a few moments now. This is a beginner level session. So I do want to talk a little bit about what Azure Synapse Analytics really is. So Azure Synapse Analytics, it provides a unified experience and it brings together data ingestion, big data analytics, and data warehousing, all at a cloud scale. So Azure Synapse Analytics unifies not only your data, but also your data tasks and your data teams with a limitless analytics service that literally does it all. So you can say goodbye to those data silos that you may have within your organizations. What's also really nice is that it simplifies a lot of the monotonous but necessary, what we would call data chores that every team must do. So this talks about things like securing pipelines, assigning permissions to users for each service, building firewalls, and so on. What's really nice is with Azure Synapse Analytics, all you really have to do is secure Synapse Studio, and the underlying Azure infrastructure and Azure integrations, such as with Azure Active Directory, takes care of the rest. So let's go ahead and start our Synapse Analytics data voyage with data ingestion. Data ingestion can be formed in many different ways. It could be files via SFTP, for instance, connections to external databases, batch processing, even streaming data. Azure Synapse Analytics has the ability to connect with hundreds of different data-bearing services through connectors that are defined as linked services. But let's talk a little bit conceptual right now. Let's talk about the concept of ETL, which is extract, transform, load, and ELT, which is extract, load, transform, and their differences. So ETL and ELT have a lot of common. At their core, each integration method makes it possible to move data from a source system to a data warehouse. The difference between the two actually lies in where the data is actually transformed. So ETL, or extract, transform, load, pulls the information from remote sources, transforms and cleans that and structures that data, then loads it into the data lake, databases, or data warehouses. Extract, load, transform, or ELT, similarly extracts data from one or multiple sources, but then it loads it into the target data warehouse, typically a data lake, without any transformations whatsoever. So the transformation of data in an ETL process happens after the loading of the raw data. The reason for this is because it really reduces the risk of fragile data processing as part of that ingestion routine. Landing the raw and unprepared data directly into the data lake also improves repeatability. So can you imagine when you're doing a development of a pipeline, for instance, and you go, multiple levels of refinement down, and then you find out that there's a problem. What's really nice about the ELT approach is because you've landed that raw data, you don't have to go back out to the source systems to retrieve that raw data again to retest your pipelines. You can actually go back as far as the raw data that you've landed in the data lake and repeat that process over and over again until you figured out what your bug is, or what implementation process that you need to perform. Another reason that ELT is a good idea is network connectivity. So again, connectivity is one of the most riskiest things. You have to depend on an external system to be up and ready to serve the data. So what's really nice about the ELT process is you're able to grab that raw data, and after that initial load, the risk is then eliminated because that raw data is already inside of your data lake. So once landed in your data lake, further processes can be defined to refine, transform, and enhance your data. So each level of refinement is typically stored separately. I've seen a lot of people, a lot of organizations favor the common Databricks approach of bronze for raw, silver for refined, gold for aggregated or queryable data. So let's start discussing how to move data into the data lake using some of the tools available in Azure Synapse Analytics. So in this diagram, you can see that there's 4 major components to moving data with Azure Synapse Analytics. At a high level, there's pipelines, and those pipelines are made up of activities. So here we have a pipeline, has a bunch of activities. And these activities could be anything from like a poly-based copy activity, Spark notebooks, data flows, stored procedures, many more different types of activities that are available. We'll be seeing those later in a demo. These activities consume or produce data described by what's called a data set. So this could be tables in a database, CSV files, Parquet files, and more. And the link service actually represents the external compute of the source system. So this is a pointer to where the data resides. So let's talk a little bit more about linked services. So the first piece of the puzzle when we're talking about a data pipeline is connectivity, and that's where linked services come into play. There's over 100 connection options ranging from common data stores like SQL, Oracle, Netezza, to protocol-based options like REST and FTPS. So the link service itself, I like to think of as a connection string essentially to those external services. What's also nice is that there's full support for Key Vault is available to ensure that you're able to secure all your secrets. One thing to note though is in order to leverage Key Vault secrets inside of your definitions of link services, the Key Vault also must be added as a link service itself. So to authenticate to the Key Vault, what you're going to do is you're going to leverage the Synapse workspace managed identity and grant it permissions to the Key Vault using an access policy with get and list privileges. So link services can also leverage the managed identity of the Synapse workspace to establish secured connectivity to other Azure-based services, things like storage accounts, for instance. But you just want to make sure that when you are using the MSI, that you award the appropriate rights to the workspace identity on the services that you're connecting to. Let's talk a little bit about the next little block, and that would be integration data set. So an integration data set is a specification for the data that is engaged in a data pipeline and its activities. So when you're working with a data pipeline, a data set will always describe the source of the data and the sink, which is the destination of the data. So a data set can describe the schema of the data, the file types involved, and the path of the data within the data source itself. A data set is also associated with a link service that points to the compute where the data physically resides. One thing I want you to take home here is it's important to note that the information stored with an integration data set is only metadata. So there's no actual storing or caching of the actual data within an integration data set. It's literally metadata that explains the shape and the location, if you will, of the data itself. And next thing is the pipeline and the pipeline activities. So pipelines is where, as you fully expect, that's where the magic happens. So data pipelines are created for data workloads. So you can have like ingestion, transformation, enhancement, whatever you need. Data pipelines are authored on a visual canvas within Synapse Studio, and they're composed of various activities and control structures that'll help you visually orchestrate your data workloads. So these activities could be things like, again, the copy activities, notebook executions, even machine learning enhancement, if you will. And there's also a bunch of different control structures that you can use for branching conditions, looping, or wait operations. And of course, the visual canvas itself makes composing data pipelines a really great experience. Next up is the integration runtime. So this is actually the compute that powers the execution of Azure Synapse pipeline. So there's three flavors that are available. The first one is the Azure integration runtime, and that's used to connect and move data from various cloud-based sources. It is serverless and automatically scales. So if you have one thing that I do want to make note of, though, is if you do have multiple data flow activities in your pipeline, there's a newer feature that has been released called the time to live, or the Azure Integration Runtime TTL. If you do foresee using a lot of data flows, it's great to use this TTL version, or setting a TTL on the Azure Integration Runtime, so that each activity doesn't pay the startup price of provisioning cluster. So it won't have to acquire compute on each activity. So that's one performance thing to keep in mind. The second one is the self-hosted integration runtime, and that's used to connect to on-premises data stores. So essentially, there's a piece of software that can be run on Windows-based machines that will essentially bridge that connectivity between your Synapse workspace and your on-premises data sources. So you have the option of installing onto a single node, but if you wanted to have scalability, you can go up to 4 nodes. One thing that I do want to make note here is that you do not have the ability to run data flow activities on a self-hosted integration runtime. So in those cases, what again we recommend is go back, obtain the data that you need to run the data flows in, bring that data into your data lake, and then have a separate Azure integration runtime do the actual processing on the data there if it requires data flow activities. And finally, another newcomer on the block is the Azure SSIS integration runtime. And this will allow you to lift and shift your existing SSIS workloads into Azure Synapse Analytics. So I am a big fan of visuals. So here is a very, very general view of the parts that go into moving data from a source to a destination via Synapse pipeline. So here you can see that on the left, we have a data set that includes a reference to a link service that contains connection information for the source compute that houses the data. The data set also contains specific on the data that is to be moved via the pipeline. The pipeline itself is made up of different activities that leverage the data set to connect to the source compute to retrieve the data specified in the data set, and essentially uses like copy activity or data flow activity, what have you, to move to the destination. So the destination has essentially the exact same format as the source, but in this case, we're going to be writing the data. So the destination is defined as a data set as well, indicating where the data is written. So this isn't a 100% picture. It's not the end all be all. You can still have a pipeline move data without the definition of data sets or linked services. If you wanted to, you can have a pipeline that executes a Synapse notebook, for instance, and uses languages such as Python or Scala to perform the operations. I do, however, recommend using the linked service dataset infrastructure, because this allows that separation concerns when ingesting the data. So in the cases where you want to use Synapse Spark, for instance, to perform additional refinements, I would recommend doing the data ingestion exactly how you see it here, and then have a separate activity that will use the notebook to further refine the data later on. Another thing too is you aren't going to be sprinkling credentials around all over the place. Now, Synapse pipelines need to be triggered in order to run. So there's 4 different types of triggers available. There's a scheduled trigger that invokes a pipeline on a wall clock schedule. So this could be daily, hourly, every 5 minutes, what have you. There's a tumbling window trigger that operates on a periodic interval, and it also retains the states. So tumbling windows are essentially a series of fixed size, non-overlapping, and contiguous time intervals. An event-based trigger responds exactly to that. It's an event. So that could be something like a file being dropped into a storage account or an event from Event Grid. The on-demand trigger allows you to execute a pipeline at will. So this is actually available to you within Synapse Studio when you're editing your pipeline. So directly on the pipeline canvas, you can add a trigger now, essentially, to trigger a pipeline on demand. All right, so let's go ahead and move into a demo. So here I have a pre-deployed Synapse environment. So let's go ahead and start looking at the full pipeline. So we have a full movie pipeline here. Let me go ahead and close that off. And what we're looking at now is the pipeline's visual canvas. So activities can be linked together. So here we have one activity, which is, let me go ahead and close that real quick. We have an execute pipeline activity, and there's also different exit conditions, if you will, based off of the activity. So here you can see that we have an on success, which is indicated by this green arrow. If I wanted to have an on failure, I can also do an on failure. Obviously, I don't really want to do that, but I just wanted to show you that based off of the exit conditions of the activities, you can do differing subsequent activities based on that status. So for some reason, I can't get a hold of that. Oh, there we go. Boom. All right. So here's our visual canvas. Remember, I talked about the triggers. There's the add trigger now if you wanted to use that. But we also have an execute pipeline. So pipelines can be nested within other pipelines, as made evident by this execute pipeline. So if I want to, I can actually double click on that execute pipeline. This brings up a secondary pipeline, which again has more nested pipelines. So you can have pipelineception, I guess you can call it. So this raw ingestion and refinement pipeline executes a couple child pipelines, but now we have different activities as well. You'll see that we have a notebook activity and we have a data flow activity. So there's multiple different types of activities that we can use throughout throughout defining your canvas or orchestrating your data workload. So let's go ahead and we're going to dive a little bit deeper into the movie header raw JSON pipeline. All right, so here's another visual canvas, and it has multiple activities here as well. So it has a delete activity, it has a web activity, a set variable activity, and a for each activity. So one thing to note here is that we have our movie ingestion process, and I just want you to take home that this is a wholesale data ingestion, meaning that we get a full, fresh copy of the data each time. Don't really care about the historical archiving of the data. If you wanted to move an archive, you can do that as well. But in this case, we don't really care. So we have a delete activity. And this delete activity needs to be pointed to a source. So the source itself is by a data set. So remember, the data set essentially is a pointer to the data within an external compute service. So let's take a quick look at this raw movies JSON. So if I want to go ahead and delete the data pointing at this raw movies JSON, what exactly am I deleting? So let's open this up. And now we can see that we have our data set definition. Again, this is all metadata. I'm not writing any code for this. This JSON data has a linked service, which is our data lake. And I can go ahead and take a look at that. So here's our data lake linked service. You can see it's using the managed identity, and it's accessing my data lake via URL in this case. So I can test the connection to it. Boom, it says successful. So it's using the connection to my storage account. And it's saying that the file path within the storage account is going to be this raw tmdb/movies JSON folder. So let's go ahead and take a look at what that looks like. So inside of Synapse, I can go into the data hub, go into linked, and I can navigate through my actual data lake through the data explorer, if you will. So I want to go into, in this case, raw TMDB movies JSON. There's raw TMDB movies JSON. And you can see that we have a whole bunch of different JSON files in there. And if I wanted to, I can also preview the data. So here you can see, yep, it's definitely JSON data. That's really cool looking. And I'll say, okay. So what's important here to note is that I have not left Synapse Studio. I was able to look at my files in storage, look at a preview of the file. I can also query it with the serverless extension as well, a serverless SQL endpoint if I wanted to as well. But in this case, I just want to come back and I now know that this delete operation is going to be removing essentially my raw JSON files that we just looked at inside of storage. Let's take a minute now, though, to take a look at some of the activities that are available. So here's different areas that you can be drilled into. So we have Synapse-based activities, which can be notebooks, Spark jobs, or stored procedures within our dedicated SQL pool. We also have a copy data and data flow. So most of the pipelines that you're going to develop over time typically will be using either copy data or data flows, depending on how you develop your pipelines. But this is where I spend most of my time. You also have the ability to do things like call Azure functions using a batch service. So if you had like PowerShell scripts that you need to run on a server, for instance, you can use a custom activity in the batch service to link towards that batch server. You can link into any Databricks services that you have a linked service to. One thing that I do want to show you here, though, is that we have iteration and conditionals. You see that where you're actually using one here, where we're saying for each page, but you can have other things for filters for each if condition, switch, or until. So a whole bunch of different types of activities that you can use to compose your pipelines. So back to our pipeline here, we're deleting the previous day's files. Then I just have a regular HTTP call that's essentially replicating a single call into the REST endpoint of the TMDB API. So the TMDB API is a free API that you can use to get movie-related data. So in this case, what I'm caring about is I'm kind of like doing a dummy call, essentially, if you will, to obtain the number of pages that I'm interested in coming back. So in reality, when you're working with especially REST-based services, you typically have, they don't give you all the data in one request. Typically it's like page 1 of data, page 2 of data, page 3 of data. And that is how this TMDB endpoint runs. So here you can see that I'm doing an HTTP call out to the movie DB, which is the TMDB endpoint. And I'm passing in the API key and the language and whatever company IDs I want to filter by. And out of that, what I'm able to grab is the actual output of the previous activity. So the output is essentially going to be a REST-based result. So inside of that REST-based result, we have the total number of pages. And what I'm doing here is I'm actually creating a numerical array that has like page 1, page 2, page 3, page 4, page 5, based off of the total pages returned. So this range is creating that array for me. And now I have something to iterate over. So based off of the number of pages returned, I want to iterate a call back into the service to obtain the actual header information from that discovery endpoint. So here's a for each, and this construct will allow me to say for each page inside of this array. So again, that array of 1, 2, 3, 4, 5, 6, 7, whatever number of pages, I want you to iterate a specific activity. So let's go take a look at what this activity is, and it's a straight up copy data. So let's take a look at this copy data and what it's doing. So the source in this case is the TMDB movie discovery REST connection string, or link service, I guess you could say. So here's that link service. It uses the TMDB API. So this is actually the data set. It's REST-based. So the TMDB API is just essentially says it's an anonymous call. We pass in the API key on the query string, but you have the ability to set the authentication type as well. But in this case, it's the movie database here. And this data set takes in some parameters, which is the API key, the with company. So again, this is a filter that I've defined. And then of course, the page of data that's being requested. So these are a parameterized data set. So it's using the REST-based API identified with the linked service. It has the base URL, and then essentially it builds the request API, the request URL here based off of the parameters that are passed in. Okay, so this copy data takes the parameters from the pipeline, and this item here will identify the item in the array. So if it's page 1, it'll be 1. If it's page 2, it'll be 2, page 3, 3, and so on, so forth. So it's actually going to go out and hit that REST-based endpoint, grab that JSON data, but now where does it go, right? And that is defined by a sync. And here's our raw movie JSON. So remember, we cleared out that folder. Now it's ready to get new data. And it's getting new data through this copy data activity. So this raw movie JSON, if you remember, it's going to store that data in the raw TMDB movies JSON folder. So that is what that pipeline is doing. All right. So let's take just a quick moment here and talk about where the linked services are managed. So let's go into the manage. We can go into linked services, and you can see that we have multiple linked services here. I wanted to pay closer attention to the key vault. So the key vault uses the managed identity of the key vault itself. You can use the Azure subscription to essentially drill into your location, or you can enter the key vault URL right here. But again, it's going to access the key vault using the managed identity, and that managed identity has been granted the get and the list privileges in the key vault. So it's able to get those secrets. So later on, if I wanted to create a new linked service, and again, here's the hundreds of different connectors that you might have. Let's just pretend, I don't know, we'll say that we're going to add an Oracle connection. I can hit continue, and you see that I'm able to set a connection string here. You can use key vault for the entire connection string. Alternatively, you can use key vault just for the password. So, but what's really nice again is because it has get and list, I'm able to take a look at the secrets that are available to me. So there's different secrets that I can pull in based off of the secrets that I have stored inside of Key Vault. So let me go ahead and discard those changes. All right. So now that we've gone through, we'll go back to our integrate here. We have our pipeline. Okay, so that's really good. We now know that we're getting our raw data. Now, remember I talked to you a little bit about levels of refinement. So we have raw JSON data. What I'd really like to do is take those JSON data results and store them in Parquet format. So let's go ahead and take a look at that. So here's our movie header refine Parquet pipeline. Let's go ahead and double click on that. And now we have something called a data flow activity. And the data flow activity is going to be running the data flow transformations of movie header refined. So let's go ahead and take a look at that. So data flows are essentially a way to author moving and transforming data visually. So a data flow always starts and ends with a data source, or a data set, I should say. In this case, you can see that we have our movie header raw. So again, this is pointing to that raw movie JSON folder that we have. We can perform any number of different activities on it. So there's multiple that are available. You can see that we have branching. We also have derived columns, aggregates, pivots, unpivots, multiple different types of activities that you can compose data transformation. So what I can do is, one thing that I did before starting this session is I turned on data flow debug. Data flow debug will take a few minutes because underneath the covers, it's actually creating um, a Spark cluster to service the actual reading of the data. So let's take a look at the data preview. So if I hit refresh on this, it'll go ahead and it will identify for me a sampling of the data that's available in this area. So let's give that a moment to go. So one of the things while we're waiting for that data preview to read the data that I wanted to show you is that within the raw movie JSON, the schema is also being able to be interpreted. So you can say import schema, and it'll essentially take a look at the files that are available and identify any structure that is available to it. Now, this is optional, but it does go a long way in helping you if you have consistent data. So on your data set itself, you can define the schema by importing the schema itself. So let's take a look if we have our data back yet. Yes, we do. So we can see that we have page, we have results, total pages, and total results. Now, I don't really care when I'm trying to refine my data. I don't care which page number it came from. I don't care about the total number of pages or the total results. What I'm really interested in is this results array. So what I need to do is I need to extract essentially the data of the movie header out of this results. And I'm going to do that via a flatten activity. So here's the flatten, and it's going to say unroll by results. So that is my array. The unroll root is results. And then what I'm doing here is I'm actually providing a mapping of the properties within the object stored in that results array, and I'm projecting it as a new column, if you will, to be stored inside of my data lake. So this is, again, taking the properties of the objects out of the array and flattening them. So if I take a look at my data now, instead of seeing page number and page results and total number of pages, we're actually going to see the data flattened. So you can see that it's the Boolean. If it's adult, has a backdrop draft, I'm able to pull out the information from the array and then leave behind the stuff that I don't need, which is like the page numbers and total number of pages. And then what I'm going to do is I'm going to store that inside of my refined layer, if you will, within my data lake. So let's take a look here. It says it's going to be using the data set. This time it's using a Parquet data set called the refined TMDB movie Parquet. So if I open this one, you'll see that it's going to be storing inside of refined TMDB / movies Parquet. So if I come back to my data, I have the ability to go into my refined TMDB and find the movies Parquet. And you can see that there's multiple Parquet files available here. So that is essentially what it's doing, is it's taking the JSON data that we read into raw, and we're refining it into a Parquet structure and storing it back into our data lake inside of a columnar format. All right, let me see here. Okay, so that is what the data flow of refined movie header is doing. So again, this didn't have to be a pipeline. I could have had the data flow activity here, but that's really up to you how you define that. All right, so now, up until now, I've only used graphical tools for moving and transforming data. But if you are a code warrior, you have the option of using code to perform these exact same operations. And one of the popular coding approaches is using Synapse notebooks. So here's a notebook activity that's saying ingest raw movie details. So we've obtained raw movie header information. Now I want to take that header information and do a separate call to find more details about the movie. So there's a separate movie endpoint within the TMDB API that'll allow me to get movie details. So let's take a look at how we can do that programmatically. So I'm going to go into settings here. I'm also going to expand this base parameters. So you're able to communicate. You saw how we can communicate from activity to activity. You also have the ability to send parameters from your pipeline into your coded activities. So in this case, I'm going to be sending in the TMDB API key from the pipeline into the notebook. So let's take a look at the notebook. All right. So here's what the movie details raw ingestion looks like. So we have an API key. So this is a parameter cell. So inside of, let me go ahead and just do that. So probably like me a little bit better. But essentially this first parameter cell, you can see that it's denoted as parameters. This is available to you through the ellipsis command here. You can say toggle parameter cell. So essentially any tokens that you define within this parameter cell can be overwritten by values passed in through the pipeline. If no value is passed in, it will use the default that you have defined here. But essentially what happens underneath the covers is when this notebook is run, it'll actually insert another cell here and pass in and overwrite the variable values here. But anyway, as I mentioned earlier, that this is a programmatic way for us to take the movie IDs from the movies that we ingested the header information for, and in turn access the movie details endpoint, if you will, to obtain more information about the movies. So I have some variables that are defined here. We have our details raw path. So this is going to be where I'm going to store the JSON results of that movie details endpoint call. So again, this is going to be raw data representing the message received from the movie details endpoint. Here we have the movie header path. The movie header path is, if you remember, we went through and we refined our movies JSON into a columnar format, and we stored it inside of our refined TMDB in the movies parquet. So this is actually going to read the parquet files that we just wrote from our data pipeline. Here's our details REST endpoint. So this is just defining the HTTP call that we're going to use to obtain the movie details. So this is the movie endpoint. I'm going to be tokenizing here by movie ID. And here's where I'm going to be using the API key. It's going to be passed in. And again, that's passed in essentially through the pipeline itself. So the first thing that I'm going to do is I'm going to generate a list for every movie that I have header information from. I'm going to generate a movie details endpoint URL. So essentially obtaining a list of movie detail endpoints for each movie that we've retrieved. So that's what this function is doing, is essentially creating and replacing that token of the movie ID with the movie ID that's passed in. So to get the list of the movie IDs, I'm actually reading the parquet files that we just wrote. I'm obtaining the movie IDs, selecting distinct of movie IDs, and then collecting it. So essentially, this movie IDs is just a list of movie IDs. And then I'm generating that URL list by calling this gen detail URL with the movie IDs that I passed in. So again, request list is going to have a bunch of URLs in it. Then I'm using the async IO and IO HTTP libraries, and essentially allowing that to request that information for movie details in parallel for me. So this will actually take just a matter of like 30, 40 seconds to run 380 requests. So that is a way for us to ingest based off of the movie details passed in. So here you can see I'm obtaining the response, and then I'm storing it inside of that details raw path. So again, that raw TMDB movie details, and writing the details.json. So if I come out to our data again, if I expand that, you can see that inside of raw TMDB, I have the movie details JSON, and this represents, again, the data that we just wrote from our notebook. So I can preview that data, and you can see that we have movie detail information. So that is what that is doing. So I'm going to close that for now. And then I'm doing a similar activity using a data flow to take those results that we just wrote for the movie details, and then we're going to transform that into a Parquet format as well. So let's open that and take a quick look. I also snuck in a couple other things in here, but really the writing of this movie details JSON to movie details refined, it's already columnar, so I was able just to grab it and move it. I also have some global things, so genres that are defined by TMDB. I created a JSON document for that, and then the configuration as well. So that is just some extra things that I threw in there. Sure, sure.
Difference between Data Factory and Synapse Analytics, and that's from the chat.
Yeah, so that I did not explain that. And essentially, one thing to keep in mind is while they are two products, they share the same source code basis. So previously, some of the things that you weren't able to do within Azure Synapse Analytics was SSIS. Now that has recently been added, but that was one of the differences before that ADF could do and that Synapse couldn't. Now there is an article, and I don't have the link handy, that shows all of the different types, like different differences between the two. But at the end of the day, I would probably say 90% of the functionality that you have inside of ADF is also available inside of Azure Synapse Analytics pipelines. So even down to the point where if you exported the JSON data, JSON documents representing your pipeline, for instance. So what I'm talking about here is if you go into the code, you'll see that every asset within Azure Synapse Analytics is stored as JSON. So you can actually copy that to clipboard, or if you're using source control, for instance, you can move those JSON files over and import them directly into Azure Synapse Analytics. So technically, different products, same basis, same foundation. So most of what you can do inside of ADF, you can do within Synapse pipelines.
Okay, and they said thank you in the chat, so I'll turn it back over to you for the last 8 minutes.
All right, sounds good. All right, so now what we've done is, so we've done the raw ingestion refinement pipeline. We went through and we've refined it. I'm just going to kind of glance over some of these things. The curate and enrich, I am setting up a logical data warehouse here. What a logical data warehouse is essentially a queryable data store that sits on top of your storage. So in our case here, we can take a quick look at the logical data warehouse. You can see that I've created a database called curated movies, where I'm taking the refined data and essentially molding it some more into the structure that I essentially want to shape it to before I get to my dedicated SQL pool, which will be essentially my gold standard or source of truth. So there I have that as well. And then I have some enhancement happening. So these notebooks essentially contain logic relative to building a recommendation engine based off of customer behavior on the movie's website. So that's what these are doing. So now what we have is we have a pipeline that we did the raw ingestion and refinement. We did the curation and enrichment. So curation meaning setting up that logical data warehouse, make it queryable. And then finally, we have our data warehouse population, where I have two data flows, one for populating the dimensions and one for populating the facts. I can take a quick look at those. I just want to make sure that I have enough time here for getting through some best practices. But you can see that I have dimensions that are created within my dedicated SQL pool, in this case, for behaviors, customers, genres, for instance. So multiple different activities. We also have lookups. So if I need to look up keys based off something that I wrote earlier, I can do that. One thing to note here too, though, is if I just select the canvas in the data flow, I'm able to set the order. So I can say that I want all of these dimensions to be populated before this one. So obviously dim movie genre has to come after movie and genre are written. So you can see that we have genre and movie setting at level 1, and then movie genre sitting at level 2. So those are available to do. So again, code for wanted to show you. Let's talk about monitoring. So let's go ahead and take a look at our pipeline runs, and we'll do the last, I think it was in the last 7 days. Nope, last 30 days. There we go. All right. Now we have our monitoring. So to monitor your pipeline runs, you would go inside of the pipeline. You can see that my full movie pipeline has been run. And then each of the child pipelines will also be given a row, essentially, if you will, on this table. So I'm able to do things like take a look at the parameters that are passed in for each of the pipeline runs. I'm also able to dive directly into the details of the pipeline run. So here you can see the execution of the pipelines, and we could drill into those. Remember, there are different line items inside of the monitoring tool, but I can also go in and take a look at the execution of the notebook. So I'm able to see the cells that actually executed and the output. So you can see that it took 32 seconds to pull in 381 movie details rows. So I'm able to see that level of detail from here. Same goes for data flows. You can select this glasses, if you will, and you can take a look and see at the different processing times, for instance, and the number of rows written. So let's take a look at the lineage. So the lineage comes in handy too when you're finding, obviously this isn't the most exciting lineage here, but you can actually find out where your data was sourced from to be able to have that data lineage back to the source. So really powerful functionality there. So let's take another quick run through some best practices. So let's start with loading data. So it's always a good idea to load data in its raw form to the data lake as quickly as possible. So the initial load is always the riskiest. We're dependent on that source system to be available and have connectivity. And by loading the data lake first, you're able to debug and develop more data workloads without having to go back to those source systems each time. When you are loading into a dedicated SQL pool, depending on the complexity of the transformations and the amount of data, it's always a good idea to load data initially into staging tables. It's also a good idea to create a user with a workload classifier with high importance and workload isolation to reserve a larger chunk of that compute. So if you go just with a default user configuration, it will only ever use a small fraction of the resources available at regular, like a normal importance. So you also have the ability to temporarily scale the SQL pool for specific long-running workloads. So if you want to essentially double your DWU or your data warehouse units, you can have that time of ingestion. Now, one thing to note here is it applies only to DWU 500C and greater, because that's when you start adding additional physical nodes. Next, let's talk about how to organize your data lake for performance. So the left image demonstrates partition data via a folder structure. So partitioning data in this way will enable faster queries for specific data by allowing something called partition pruning or elimination. So for example, if you needed to query data for a particular day, you can run a query pointing directly at the day folder to limit the amount of data that's searched. So it avoids things like full scans of the data lake. In storage, it's also good to ensure that there's not too many files written. A rule of thumb is for your files to be 1 to 2 gigabytes in size. Another thing to keep an eye on is having too many small files. This will cause high I/O on the storage systems, resulting in throttling. So again, another good rule of thumb here is have 3 to 4 times as many files as the number of cores that you have in your pool. And you can run a compaction process if you wanted to merge the files into larger ones if need be. So the recommended file type, if I haven't mentioned before, for big data is Parquet. So you notice when we grabbed our JSON data, we did land it in raw format, and that's fine. But for each level of refinement there forward, we used Parquet. So even our logical data warehouse has Parquet underneath the scenes. So Parquet is an open source columnar file format that has several optimizations compared to the row store. So again, compression, predicate pushdown, support for file partitioning, and better performance when it comes to other file formats. So with Parquet, you can also take advantage of that partitioning within the files, again, avoiding full scans of data within the file itself. And that's what's shown here on the right-hand side. So you can see we have day, month, year, goes into city. So here's our Parquet file, has city, New York, and Seattle partitioned within the file itself. Okay.
We may have a minute or two because it's at lunch.
All right, I'll go very fast.
Okay.
All right. Distribution, round robin staging, hash distribution, fact, replicated dimension tables. And these slides are available, so download them. Indexing, CCI might not be your best bet. Make sure that if you are using CCI, typically a rule of thumb is 1 million rows by 60 distributions by the number of partitions. Clustered indexes, even if you have a very large table, if you're always returning a single or few rows, the clustered index may outperform CCI. Heap tables, used for staging. Secondary non-clustered indexes can be used at your discretion to improve performance, but again, use caution because it'll increase your table storage and data load processing. More indexes is more overhead. Spark, use things like hyperspace indexes, koalas versus pandas. Pandas is single threaded, whereas koalas is parallel. UDFs are also single threaded, so use built-in functions instead. And again, use Parquet. When reading data, use Microsoft developed connectors, again, parallel versus serial. So with that, I'd like to thank you, and please take some time, provide some feedback on the session, help plant some trees, and win some cool prizes. Thank you for attending my session, and please feel free to contact me at any time.
Thank you.